Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my lecture on our laboratory subject of IT 128, Quantitative Methods. Let us learn today multiple linear regression. Multiple linear regression is a method for analyzing relationships involving more than two independent variables or predictors. The multiple linear regression is represented by this formula. Y is equal to beta sub 0 plus beta sub 1 multiplied by x sub 1 plus beta sub 2 multiplied by x sub 2 plus beta sub I multiplied by x sub I plus the epsilon, where beta sub 0 is the y-intercept, beta sub 1 is the slope of y with variable x sub 1 holding variables x sub 2, x sub 3 until x sub I constants. Beta sub 2 is the slope of y with variable x sub 2 holding variables x sub 1, x sub 3 until x sub I constants. X sub I is the predictor or independent variable. Epsilon is the error or residual. And then the variable y is the response or outcome or dependent variable. The dependent variable y is specified as the sum of the intercept term beta sub 0 plus the product of the estimated beta value and the x values for each of the I features. The best way to understand multiple linear regression is to study this example, mile per gallon. The mile per gallon is the amount of gasoline or diesel consumed by the car in miles per gallon. The table shows the different car models with their miles per gallon, cylinder displacement, horsepower, and weight. The cylinder displacement, horsepower, and weight are the multiple independent variables or predictors, while the mile per gallon MPG is the dependent variable or response variable or outcome variable y. MPG stands for mile per gallon, DISP, this is cylinder displacement, HP is horsepower, WT is the weight of the car in tons. What will be the mile per gallon of a new car that has a cylinder displacement of 221, horsepower of 102, and weight of 2.91 ton? Using GNU Octave, we can determine the multiple linear regression model. Y is equal to 39.4144 18 plus 0.029988 multiplied by cylinder displacement minus 0.058501 multiplied by the horsepower minus 6.161487 multiplied by the weight. By substituting the value of the cylinder displacement to 221, horsepower to 102, and then the weight to 2.91, the forecast mile per gallon is 22.14 miles per gallon. That means that the new car consumes gasoline or diesel 22.14 miles per gallon. The car can travel 22.14 miles and it will consume 1 gallon of diesel or gasoline. Adjusted coefficient of determination R square. In multiple linear regression, it is better to analyze the adjusted coefficient of determination R square rather than the coefficient of determination R square, because the multiple coefficient of determination R square has a serious flow As more variables are included, R square increases. R square could remain the same, but it usually increases. The largest R square is obtained by simply including of all the available variables, but the best multiple regression equation does not necessarily use all of the available variables. Because of that flow, comparison of different multiple regression equations is better accomplished with the adjusted coefficient of determination, which is R squared, adjusted for the number of variables and the sample size. The formula for the adjusted coefficient of determination R squared is equal to 1 minus quantity n minus 1 multiplied by quantity 1 minus R squared divided by n minus quantity x plus 1, where R squared is the adjusted coefficient of determination, n is the sample size or number of cases, and k is the number of independent variables in the regression equation. Interpreting the coefficient of determination R squared and the adjusted coefficient of determination R squared. Use the decision chart below to interpret either the coefficient of determination R squared and then an adjusted coefficient of determination R squared. For example, the cricket chirp temperature has 0.760801 coefficient of determination. That means very high relationship between the two variables x and y, the chirps per second and temperature in degrees Celsius. Therefore, it has a very high or strong prediction. A value of 0 indicates no correlation between the x and y variables. An R square containing a value of 1, that means it is a perfect correlation. An R square that falls within the range from 0.75 to 1 indicates very high correlation. An R square falls in the range from 0.50 to 0.75, that means it is a high correlation. An R square that falls within the range from 0.25 to 0.50, it is moderately small correlation. An R square that falls within the range from 0 to 0.25 indicates very small correlation. We will not tackle in depth about other statistical methods such as hypothesis testing, level of significance, z-test, t-test, f-test, p-value, chi-square, ANOVA, because we focus much on computational models rather than pure statistics subject. You passed the statistics subject in your first year subject. I assume you studied those statistical methods. By reading plenty of books, one can learn anything in this world. The regress built-in function from the statistics package computes the multiple linear regression using least squares fit of y on x with the model y is equal to beta sub 0 plus beta sub 1 multiplied by x sub 1 plus beta sub 2 multiplied by x sub 2 plus beta sub I multiplied by x sub I plus epsilon, where x is the independent variable that you need to pass. Y is the dependent variable that you will also pass as an argument when calling the built-in function regress. Alpha is the significance level used to calculate the confidence intervals Bn and Rin. If not specified, alpha defaults to 0.05 or 5% of error. The output of the regress command will return B, the polynomial coefficients, B int confidence interval for B, R column vector of residuals, R int confidence interval for R, stats that contains an array of values, R squared, the F test, the P value, and the estimated error of variance. The RCO plot or residual case order plot displays an error bar plot of the confidence intervals on the residuals from a regression. The residuals appear in the plot in case order. Inputs R and Rint are outputs from the regress function. Use the RCO plot to determine outlier in multiple linear regression. We pass two arguments, the values of R and the values of Rint, which are the results taken from the calling of the regress function. The left RCO plot graph has no outlier because all the residuals contain 0. This indicates that the residual is smaller than 95% of new observations and if alpha is set to 0.05 or 5%. While the right RCO plot graph, the interval around the second residual, shown in red, does not contain 0. This indicates that the residual is larger than expected in 95% of new observations and if alpha is set to 0.05 or 5% of error, and it suggests that this data point is an outlier. The following codes are taken from the laboratory hands-on activity number 6. First and foremost, you must install the statistical package before you run and test this code. The pkg load statistics command will load the statistics package into the memory. The variable disp is a 6 by 1 matrix that contains the cylinder displacement of the 6 cars. The variable HP is a 6 by 1 matrix that contains the horsepower of the 6 cars. The variable weight is a 6 by 1 matrix that contains the weight in tons of the 6 cars. Whereas the variable Y is a 6 by 1 matrix that contains the actual miles per gallon of the 6 cars. The variable N contains the length of Y, which is 6, a sample size or number of cases. Correlation is a relationship between two variables X and Y. The built-in function cor computes the matrix of correlation coefficient. This line computes the correlation between the cylinder displacement and miles per gallon. The next line computes the correlation between horsepower and the miles per gallon or the variable Y. The last line computes the correlation between weight and the miles per gallon or the dependent variable Y. Interpreting the coefficient of correlation R. Use the chart below to interpret the coefficient of correlation R. For example, the coefficient of correlation R between cylinder displacement and mile per gallon is negative 0.6889418. That means high negative correlation. Therefore, the cylinder displacement and miles per gallon have high negative correlation or strong relationship between the two. Moreover, as the displacement increases, the miles per gallon decreases. A negative 1 correlation R, coefficient of correlation R indicates a perfect negative correlation. A positive 1 coefficient of correlation R indicates perfect positive correlation. A coefficient of correlation R that falls within the range from 0.50 to 0.75 indicates high positive correlation. A coefficient of correlation R that falls within the range from negative 0.50 to negative 0.75 indicates high negative correlation. A value of 0 for the coefficient of correlation indicates no correlation or no relationship between the two variables x and y. The following GNU codes are taken from the laboratory hands-on activity number 6. To set up the determination of multiple linear regression model for the 6 cars or the miles per gallon, we first join the matrix, cylinder displacement, the horsepower, the weight together with a coulombs of 1. The variable x contains a 6x4 matrix values of coulombs of 1, coulombs of cylinder displacement, coulombs of horsepower, and finally, the last coulombs of weight. The built-in function once returns a matrix or n-dimensional array whose elements are all 1. For example, the variable matrix is equal to ones, 2 arguments passed 3 and 1 indicating the size of the matrix, which is 3 rows by 1 column. This built-in function once will return a 3 by 1 size of matrix containing a values of 1. The statistical built-in function regress, we need to set up that the first column must have all ones, because that is the setup to compute or determine the multiple linear regression. The first column must have all ones, and then followed by the values of the independent variables or predictors, and then we pass now the dependent values of y, which are the miles per gallon, and then the combined matrix variable capital X, and then the level of significance of error, which is 5% alpha. This regress will return the results, many results, such as the B polynomial coefficient, the B int, the R int, and then the stats. The RCO plot command is used to determine outlier. We pass 2 arguments, the variables R and Rint, which are the result when we call the regress command. The RCO plot displays this graph on the screen. The following GNU Octave codes displays the multiple linear regression computational model. The correlation are coefficient of determination. This is the multiple linear regression computational model. The correlation are the coefficient of determination r squared, the adjusted coefficient of determination r squared, the f-test statistics, the p-value, and the mean squared error of the residuals. The adjusted coefficient of determination r squared computed is 0.694975. That means that there is a high relationship among the four variables x sub 1, x sub 2, x sub 3, and y, or this cylinder displacement, horsepower, weight, and miles per gallon. Therefore, it has high or strong prediction. The subplot command set up a plot grid with rows by columns, sub-windows, and set the current axis for plotting the location given by index. For example, a plot with 2 by 2 grid will have plot indexes running as follows. This graph will be placed on the left top corner by calling subplot 2 rows, 2 columns, index 1. This graph will be placed on this right top corner by calling subplot 2 rows, 2 columns, index 2. This graph will be placed on this right bottom corner by calling subplot 2 rows, 2 columns, index number 3. This graph will be placed on this right bottom corner by calling subplot 2 rows, 2 columns, index number 4. All of the 4 graphs are placed in one window. Here are the actual codes that place the 4 graphs in one window. The code that will display this graph or scatter graph are written here after calling the subplot 2 rows, 2 columns, and index 1. The codes that will display this scatter graph are written here after we call subplot 2 rows, 2 columns, index 2. The codes that will display this scatter graph are written here after we call subplot 2 rows, 2 columns, index number 3. And then finally, this scatter graph with a red line showing the multiple linear regression line, the codes are written here after we call subplot 2 rows, 2 columns, index number 4. All the 4 graphs are placed in one window. The reshape command returns a matrix with the specified rows and columns size whose elements are taken from the matrix A. For example, the following will reshape the size 1 by 4 matrix named A, containing values 1, 2, 3, 4, into a 2 by 2 size of matrix B by calling reshape. And then we pass the first argument, the matrix, the second argument, the rows in size, and then finally the last argument, the number of columns. And it will transform this matrix 1 by 4 into a 2 by 2 matrix. The following GNU Octave codes will set up the scatter graph to plot the multiple linear regression model. The highlighted value of 100 is the size of the matrix that I specified to draw the straight line of the multiple linear regression, which is colored red. The value of 100 is not fixed. You can change to lessen or lengthen the red straight line. The following GNU Octave codes will compute the prediction using the multiple linear regression computational model. It will predict the miles per gallon if the cylinder displacement is 221, horsepower 102, and weight 2.91 tons. And it will display this result. Let us run the laboratory hands-on activity number 6. There are plenty of outputs or results listed in this command window. And we can see the computed multiple linear regression model, the coefficient of correlation R, the coefficient of determination R squared, the adjusted coefficient of determination R squared, F-test statistics, the p-value, and the mean squared error of the residuals. Also, with the standard error of the estimate, and then the prediction, together with the residual case order plot that has no outlier, the correlation coefficient between the cylinder displacement and the miles per gallon, horsepower, and then the miles per gallon, and then the weight and the miles per gallon, and the multiple linear regression line with the multiple linear regression computational model. And then finally, this scatter graph that is the same thing with this one, that shows the multiple linear regression line together with the multiple linear regression computational model. Here is your assignment. On page 20 of the laboratory manual, solve the laboratory hands-on exercise number 4. If you are assigned set A, then solve set A. Otherwise, solve set B. I posted your laboratory hands-on exercise number 4 in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.